everyone. Welcome to Subnetting a Little Bit. In today's installment, we discuss more elements of IPv4 addresses, including the following: a quick review of the native address map, explanation of the network and broadcast addresses, determining the network and broadcast address in a classful scheme, and finally, we look at the range of usable addresses. First, a quick review of the native address map. Recall, uppercase letters represent 8 bits, and each lowercase letter represents 1 bit. For Class A addresses, the first octet is between 1 and 126. The address map is N.H.H.H. The first 8 bits are network bits. This is the network portion. The last 24 bits are host bits. This is the host portion. For Class B addresses, the first octet is between 128 and 191. The address map is N.H.H. It represents 16 network bits, followed by 16 host bits. For Class C addresses, the first octet is between 192 and 223. The address map is N.N.N.H. It represents 24 network bits, followed by 8 host bits. The first address in a range of network addresses is the network address, also referred to as the network ID or subnet ID. To get the network address, set all host bits to 0. The network address cannot be assigned to a device. It is not usable. The last address in a range of network addresses is the broadcast address. Technically, it is the directed broadcast address. It is used to send traffic to all devices within a specific network. To get the broadcast address, set all host bits to 1. The broadcast address cannot be assigned. It is not usable. Let's examine how to determine the network and broadcast addresses in a classful scheme. Given the classful host address 10.135.246.57, we will determine the network and broadcast addresses. The term host address means it is an assignable or usable address. Since the first octet is 10, it is a Class A address. To obtain the network address, set all host bits to 0. This gives 10.0.0.0. To obtain the broadcast address, set all host bits to 1. This gives 10.255.255.255. In this next example, we are given the classful host address 172.16.33.200. Since the first octet is 172, it is a Class B address. To obtain the network address, set all host bits to 0. This gives 172.16.0.0. To obtain the broadcast address, set all host bits to 1. This gives 172.16.255.255. Finally, we are given the classful host address 192.168.2.10. Since the first octet is 192, it is a Class C address. To obtain the network address, set all host bits to 0. This gives 192.168.2.0. To obtain the broadcast address, set all host bits to 1. This gives 192.168.2.255. We will now determine the first usable and last usable addresses. Let's look at the given Class A network address 10.0.0.0 10.0.0. To obtain the first usable address, add 1 to the fourth octet. This gives 10.0.0.1. To obtain the last usable address, subtract 1 from the fourth octet of the broadcast. This gives 10.255.255.254. Now let's consider the given Class B network address, 172.16.0.0. To obtain the first usable address, add 1 to the fourth octet. This gives 172.16.0.1. To obtain the last usable address, subtract 1 from the fourth octet of the broadcast. This gives 172.16.255.254. Finally, we are given the Class C network address, 192.168.1.0. To obtain the first usable address, add 1 to the fourth octet. This gives 192.168.1.1. To obtain the last usable address, subtract 1 from the fourth octet of the broadcast. This gives 192.168.1.254. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.